Deeksha Karnataka YouTube channel. How are you all? Sorry, a slightly delayed stream due to various reasons, and I have somehow lost my stylus pen. But worry not, we will be doing today's session. So what we are doing today, we are basically discussing atoms and nuclei chapter. Okay, so if you see that atoms and nuclei are two sister chapters, we are going to discuss them together. Let me correct that a little bit, sorry. So what we will be doing, we will be discussing atoms and nuclei. Okay, so now if you see that in the atoms and nuclei chapter, we have how many questions? Total number of questions coming from atoms are number 3, and for nuclei it is 4. Okay, and we are going to get one MCQs from each chapters. No fill in the blanks going to come from this chapter according to your blueprint. So now what we will be doing, we will be simply moving on. We will be discussing both chapters, all the MCQs from your model paper. Okay, so let's start. First question, first we will be discussing atoms, and let me enlarge it a little bit. Correct. So now let's start. Hello Nitish, how are you? Hello Nitish H7C, Nitish HD. Okay, I hope you are able to see this. So let us start with the questions. First question, we will solve all the questions one by one. First question, in high temperature, and hopefully we will be not requiring stylus to write. So hi Pooja, how are you? So today we are solving question bank questions from the chapter atoms and nuclei. The condensed matter and dense gases at all temperature emit electromagnetic radiation. Due to, so condensed matter and dense gases at all temperature emit electromagnetic radiations due to high temperature, oscillations of atoms and molecules, inelastic collision between atoms and molecules, excitation of electrons. Let's see who can answer this question. How are you all? So this evening is very eventful for me. Something special is coming for all of you very soon. So I was working on that, and in the meantime I have lost my stylus pen which I was using to write on the board. Anyway, don't worry. So we will manage without stylus pen, right? So let's see who is answering with me. Who is answering with me? Why do we see electromagnetic radiations coming from atoms and molecules? Why do we observe EM radiations from atoms and molecules? Dense gases, for example, when we observe a star which is very far away, or a dense cloud, gas cloud in the sky, why do we see some light coming from that gas cloud, and how do we identify them? What are all the elements present in that gas cloud? And based on that we can say that whether it is a gas cloud forming a star, or it is a gas cloud that after destruction of a star. So that can also be determined based on this property. Anyone? Pradeep Shine is saying option C. Pooja is saying option B. No one has answered the correct answer. It is not oscillations of atoms and molecules. It is not inelastic collision. It is the excitation of electrons. Electrons get excited from their ground state, goes to an higher energy state, and then it comes back to its ground state, giving rise to the electromagnetic radiation. So it's simple excitation of electrons, not collision between the atoms. Collision between the atoms does not give rise to electromagnetic radiation. Electromagnetic radiation can only be provided when electron is jumping from higher energy state to lower energy state. That is the only reason for obtaining electromagnetic radiation. This is also called characteristic spectrum. Characteristic spectrum, the color that you observe or the lines that you observe, I will not say color, it can be visible range, it can be invisible outside our visible range as well, and it is called characteristic wavefront, characteristic spectrum, and it is happening because of excitation of electrons. Now statement number 2, light emitted by mercury vapor lamp is due to individual atoms between interaction. Sorry, I don't know why my scroll is not working. Let me do some undos. Now let's see. I'm not sure why my scrolling is not working. Statement: the light emitted by mercury vapor lamp is due to individual atoms but not due to interaction between atoms or molecules. The average spacing between the mercury atoms in vapor is large. Okay, both statement 1 and 2 are true, and 2 is correct explanation of 1. Both statements 1 and 2 are true, but 2 is not correct explanation number 1. Statement 1 is true, statement 2 is false, both statements are false. Let's see who can answer question number 2. Question number 2 is statement 1, the light emitted by mercury vapor lamp is due to individual atom but not due to interaction between atoms and molecules. The average spacing between the mercury atom in vapor is large. So if you consider vapor means gaseous state. So in gaseous states the molecules are or atoms are far apart. Okay, so statement 2 is correct. Okay, the statement and we know that when light is emitted by mercury vapor lamp or halogen lamp, what happens is that you excite individual atoms, and that atom is basically when electrons are coming back from ground state, coming back to ground state from higher energy state, it gives the emission back to our nature, and that's why all the principle of halogen lamp as well as mercury vapor lamp is same. You excite element, that element basically goes from ground state to higher energy state, and then when it is coming back from higher energy state to ground state, it gives back that radiation back. So this is also a correct statement. Okay, now these two are correct statement, but why mercury vapor is emitting light, that cannot be explained by because spacing is high, because even the spacing is low, the interaction will not give rise to electromagnetic radiation. So even though both statements are correct, it is not the correct explanation. Even though both statements are correct, it is not the correct explanation. Let me fix the scrolling part. Okay, now we can scroll. Question number 3. The source of alpha particle in Geiger-Marsden experiment is radium-226, bismuth-214, radon-222, cobalt-60. Okay, let's see who can answer. Hello Nagraj, how are you? Long time, after long time. Can you please answer the question? Question number 3. The source of alpha particle in Geiger-Marsden experiment. Geiger-Marsden experiment is same as Rutherford experiment. Okay, same element that is used in Rutherford experiment. Which one is used? So Nagraj is saying B. Yes, bismuth-214 is the element which is used for bismuth-214 is the one which is used for Rutherford experiment or Geiger-Marsden experiment. Okay. Next question: the thickness of gold foil in Geiger-Marsden alpha particle scattering experiment is 2.1 into 10 to the power of minus 7 millimeter, 1.2 into 10 to the power of minus 4 millimeter, 2.1 into 10 to the power of minus 4 millimeter, or 2.1 centimeter. 3B, yes, 3B is correct. Now 4, question number 4. The thickness of gold in Geiger-Marsden alpha particle experiment. Okay, the thickness of gold in Geiger-Marsden alpha particle experiment. 4A, yes, it is. So remember that we have used a very small, very thin gold foil in the experiment, so the thickness should be as small as possible, and 2.1 is 10 to the power minus 7 is as small as possible, so this is the correct answer, not the other one. Next, the detector in Geiger-Marsden alpha particle scattering experiment is coated with silver nitrate screen, phosphorescent barium sulfide, zinc sulfide. What about 5th, question number 5? The detector in Geiger-Marsden alpha particle experiment is coated with silver nitrate screen, phosphorescent barium sulfide, zinc sulfide. Yes, zinc sulfide, it actually gives phosphorescent, but phosphorescent itself does not make any sense. So when alpha particle strikes the zinc sulfide, it gives a small fluorescence that can be detected. Phosphorescent means they are already bright. Okay, so there are some elements which are already bright, for example radium. Okay, in fact radium, sulfur can also be, particular variant of sulfur can also be phosphorescent, but that they are not used. Zinc sulfide, when alpha particle strike zinc sulfide, it gives a fluorescence that can be detected using a microscope. From the kinetic theory, the size of an atom was known to be 10 to the power of minus 10 meter, 10 to the power of minus 14 meter, 10 to the power of minus 18 meter, 10 to the power of minus 22 meter. Size of the atom is 10 to the power of minus 10 meter. Okay, size of nucleus is much smaller than this. Okay, size of the nucleus is somewhat around Fermi, not even 10 to the power of minus 4 means it is even smaller than the nucleus. Size of the nucleus, remember, size of the nucleus is somewhat Fermi, okay, 10 to the power of minus 12 around. Okay, but size of the atom is 10 to the power of minus 10, minus 8 around, minus 10 to minus 8. The size of atom is about dash times larger than the size of the nucleus. 10 to the power of 2 to 10 to the power of 3, 10 to the power of 3 to 10 to the power of 4, 10 to the power of 4 to 10 to the power of 5, 10 to the power of 5 to 10 to the power of 6. Okay, now this question is slightly controversial. 7C. 7C, actually, as I mentioned, this is slightly controversial. This is also can be correct. This one can also be correct. This is I think slightly more that what you consider. So 10 to the power of 3 to 10 to the power of 4 is more accurate. Okay, if the range is given a lot of spreaded, then it could have been making any sense, because 10 to the power of 4 is actually the size of the nucleus compared to the size of the atom. Okay, 10 to the power of 4 is important, but 10 to the power of 4 to 10 to the power of 5, I don't think that much is size. It will be 10 to the power of 3 to 10 to the power of 4. The alpha particles are nuclei of hydrogen atom, deuterium atom, beryllium atom, helium atom. This is easy. Question number 8 is easy. Answer it quickly. The alpha particles are nuclei of hydrogen atom, deuterium atom, beryllium atom, helium atom. Alpha particle is, how do I write alpha particle? We write it like He24 plus plus or plus 2. So what is this? This is basically helium nuclei. So it is a nucleus of helium atom. Alpha particles are nuclei of helium atom. Okay, yes, 8D. Question number 9. Rutherford alpha particle scattering experiment determines the size of nucleus, electron, proton, neutron. So what size do we determine? Nucleus size, electron size, or proton size, or neutron size. In fact, when Rutherford did this experiment, only electron was known, proton and neutron was not known at all. Okay, so which size we determined? We determine the size of, obviously, nucleus. We determines the size of the nucleus. Okay, that's why Rutherford was credited with the discovery of nucleus, right? Geiger, Marsden, Rutherford, they all did the same experiment, slightly different. Later on they collaborated and calculated everything together. Next, the negative sign in electrostatic potential energy of an electron signifies that, so the negative sign in electrostatic potential energy. So electrostatic potential energy or total energy of electron is given by, so total energy, the electrostatic potential energy is twice of that, is given by minus 13.6 by n square, and electrostatic potential energy is 2E. This is total energy. This is total energy, and electrostatic potential energy is 2 into E. And kinetic energy is magnitude of E without the sign. Remember this. If you are preparing for kcet, this is very, very handy for all of you. The negative sign of electrostatic potential energy of an electron signifies that potential energy of an electron is unstable, electrostatic force is in the negative r direction, kinetic energy of all electron is constant, electrostatic force is repulsive. So what is the meaning of electrostatic potential energy signifies? 10, question number 10. Yes, 9A was correct. Pooja also came back. Yes, 8D was correct. Now let's see who can answer question number 10. Interesting. Potential energy of an electron is unstable, electrostatic force is in the negative r direction, kinetic energy of electron is constant, electrostatic force is repulsive. So remember, it's talking about electrostatic potential. Potential is a scalar quantity. Potential is a scalar quantity. It has nothing to do with direction unless it is relating a vector quantity. So if potential is related to a vector quantity, for example, E equals to minus dV dx, in that case it makes a sense, because that was electric field is equals to change of potential, right? But here we are only talking about electrostatic potential energy, which is basically the total energy of electron. If you know the total energy, you can also find the electrostatic potential. 10A, potential energy of an electron is unstable. No, potential energy of electron is not unstable. That is the basic of if you are considering Bohr's atomic model, electrons are stable. So that means electrostatic force is repulsive. So if you are trying to get closer, okay, you have to do some work, extra work on the system. That's why electrostatic potential is negative. In other sense, if you want to separate the electrostatic electron out of the nuclei or separate the electron and the atom, then you have to provide that extra energy to separate them. That is more clear. Okay, because the force is repulsive, electrostatic force is repulsive. Okay, this is also does not make any sense. Just a second. This is also does not make any sense. Potential energy of electron is not unstable. Negative sign in electrostatic potential energy of an electron. Now again, this question is incomplete, by the way. So they have given this chapter and somehow they have came up with the question. So possibly I think they are trying to say that electrostatic force is in the negative r direction. So if the static force is on that direction, electrostatic force is acting towards the center. But again, that does not make any sense. So electrostatic force can be towards center, outward center, but that does not make any sense. So if this is the nucleus, positive, r vector points outside, and electrostatic forces acting in this direction. That's why that maybe they are trying to say. But again, potential energy of electron is not unstable, so it is a stable electron. Electrons are orbiting a stable orbit, that's why potential energy is stable. Electrostatic force is repulsive, also does not make any sense. Electrostatic force in this particular case is attractive, it is not repulsive. Okay, so maybe they are trying to implicate this, but this is not correct explanation. Actually, if you want to separate the electron from the atom, okay, if you want to separate, you have to provide that energy to the electron, so it can come out of the electron. That's why it is negative. The emission line spectrum is the characteristics of a molecule, a solid, an atom, a liquid. So what is the emission line spectrum? So first of all, what is emission line spectrum? So if you give energy to an atom, okay, the atom will, the ground state electron will go into the higher energy state, and when the energy, the electron comes back to the ground state, it emits that electron back. And so that is a property of what? 11C, yes, it is a property of an atom. Okay, emission line, absorption line, they are all properties of atom. Atoms are only giving you spectral lines. Okay, the emission line spectrum serves as paper point of gases, photo print of gases, color print of gases, fingerprint of gases. Okay, let's see who can answer question number 12. Okay, the emission line spectrum serves as paper print of gases, photo print of gases, color print of gases, fingerprint of gases. So out of all these, which one is unique? Imagine I am a spectral line, emission spectral line. I am myself a spectral line. So what is unique about me? How can you identify? Suppose I go someone, I kill someone. Okay, tomorrow police come to my place and say that, okay, sir, you have done the crime. Now how they will say that I have done the crime? They have to do some things, right? From there they can definitely say that, okay, this is the person who has committed the crime. So for that they need something which is called fingerprint. Okay, fingerprint of gases. The emission line spectrum is called fingerprint of gases because it is unique for every person. Okay, fingerprint for every person is unique from the other person. That's why emission line spectrum is called fingerprint of gases. Okay, it is unique. So for hydrogen, whatever emission spectrum is that, for helium the spectral line will be different, for lithium it will be different, for all the elements spectral line will be different, and that based on that we can identify which element it is, and that's how we do. So mainly it is used for distant galaxies and stars. Okay, what is present inside that we determine is using the spectral lines. Next is question number 13. Bohr's atomic model imitates Sun-Earth system, Earth-Moon system, Sun-Planet system, Sun-Comet system. Muhammad Nabil, IMSC. I don't understand what are you trying to say. Muhammad Nabil, please stop spamming. Pooja is saying 13A. And Nagaraja is saying 13B. If you have something, please please mention it. I don't understand what you are trying to say. IMSC. Okay, so it is neither Sun-Earth system, it is neither Sun-Moon system, it is okay. You can say Sun-Earth system, you can say Earth-Moon system, but actually what it imitates is Sun-Planet system. Okay, it is mostly sun planet system where sun is at the center, that is nucleus is at the center. All the electrons, because even though Bohr's atomic model is not applicable beyond hydrogen, when Bohr gave his atomic theory, he says that all the electrons are orbiting around the nucleus in circular path. So basically more than one electrons are there. Sun Earth system means only sun and earth. Earth Moon system means only earth and moon. But sun and planet system means where more than one electron is there. Okay, it's not exactly imitates because sun planet system planets are rotating in a elliptical path, but because there are more than one electrons are present, sun planet is more appropriate rather than earth moon. Now I know why Nagaraja said earth and moon, because earth and moon are mostly orbit wise it's a circular orbit, but it is again not correct. Even though he did not say what is the planetary from where he took the idea from, but it is understood that it imitates sun and planet system, because in our simplified model of sun and planet we assume that all the planets are also rotating in circular path. That's how we studied in the in our childhood, right? The principal quantum number for Bohr radius is, okay, question number 14. Principal quantum number for Bohr radius is n equals to 1. Yes, n equals to 1 is the ground state. Principal quantum number for Bohr radius means the ground state radius. Ground state radius is n equals to 1. N starts from 1. The minimum energy required to free the electron from ground state of the hydrogen atom is called first excitation energy, zero potential energy, excitation energy, ionization energy. Easy question. Pooja is saying 15b. He says that the electron revolve in defined orbital. Electron revolve in defined orbits, okay, and not orbital. Orbitals concept was not there during Bohr's time. Orbitals concept came much later, okay, and it came mainly through chemical research. So Hund's law, okay, Pauli's exclusion principle, they all came afterwards. But Bohr's model was first. He says that the electrons orbit around the nuclei in fixed orbits, okay, and whenever they are orbiting in the that fixed orbit, it does not emit any energy, and electron can move from one orbit to another. Okay, so one orbit to another means there are more than one orbit present. So one orbit to another means obviously there are more than one orbit present, and normally for earth moon orbit or for sun earth orbit there is only one orbit. Electron cannot move from one orbit to another, so that is not possible. But earth planet system means more than one orbit is present. Okay, that's why it is taken as earth and planet orbit. Okay, in fact when we were kids it was used to taught us, I don't know whether it is still there or not, in class 10th chemistry it was a part of our syllabus, that where we are learning about shells etc., and it was asked that the similarity and dissimilarity between earth planet system and atomic model. The minimum energy required to free the electron from the ground state of the hydrogen atom is called, what is the answer? Pooja is saying 15D. Pooja answered 15B, later on change it to 15D. Yes, ionization energy, not 15C, Nagaraja, not excitation energy. You have freed the electron completely from the hydrogen. So if you free the electron completely from the hydrogen, that means the electron is free, so it is negative, and the hydrogen nucleus is now positive. Okay, that is a proton. So you are basically separating electron from hydrogen atom is basically you are separating proton and neutron, proton and electron. Okay, so if you can do that, that means you have a H plus and an E minus. So H plus and E minus means it's basically your you have ionized the gas. So this is an ionization energy. According to Louis de Broglie, waves associated with orbital electrons are progressive waves, stationary waves, longitudinal waves, continuous waves. Okay. Now let's see. According to Louis de Broglie, okay, this is not Louis, this is Louis de Broglie. Okay, this S remains silent. He is a German, so Louis de Broglie. Okay, Louis, some people call it Louis, but it is Louis. Louis de Broglie, waves associated with orbital electrons are, what is the answer? So Louis de Broglie says that electrons are orbiting in static waves or standing waves. That's why they are not emitting any energy, and he even calculated the angular momentum using his wave particle duality theory, and there he establishes that the ln equals to actually coming out to be integer multiple of nh by pi. Okay. Bohr's model is applicable to hydrogen atom, helium atom, lithium atom, all atoms. 16 was B, okay. 17. 17. This is a very easy question. I don't know why I am asking this question again. Yes, 16B was correct. Bohr's model is applicable to hydrogen, helium, lithium, all. Only hydrogen. Do not mark all atoms. Do not mark all atoms. No, Nagaraja. No. It is not applicable to all atoms. Bohr's model is applicable to only hydrogen and hydrogenic atom. That is one of the drawback of Bohr's model. Okay. So helium atom, it might be applicable if you take one electron out. So it is applicable for He. It is not going back. Just a second. Okay. So if it is a helium plus, if it is helium plus or lithium double plus, then you can apply Bohr's model, because helium plus has how many electrons? Only one electron. Lithium double plus will also have one electron. So only when the it does not matter how many protons are there, but in the outermost orbit there should be only one electron, then only you can apply Bohr's atomic model. Okay, so it is applicable to helium plus, applicable to lithium double plus, and all the isotopes of hydrogen. For an electron revolving around the nucleus, kinetic energy and potential energy are positive, total energy is negative. Kinetic energy is positive, potential energy and total energy are negative. Potential energy is negative, kinetic energy and total energy are negative, are positive. Kinetic energy and potential energy are negative, total energy is positive. Okay, I don't know why my controller are not coming. So let's see. So which one is correct answer? Only doing form question bank is enough, like all MCQ 2 marks and 3 marks and 5 marks, and question practicing from can I score full marks? Mohammed Nabil, if you are practicing all question bank, definitely you will score 70 out of 70. You will score 105 marks are their maximum. So if you are practicing all question bank, definitely you will get. Okay, even I don't recommend solving all the question bank questions. There are a lot of extra questions in question bank. MCQs are very, very important. You have to complete the question bank of all MCQs. That is mandatory. Other 2, 3, 5 marker questions, we are going to do some more videos. If you follow our channel, if you follow our videos, definitely you will get out of out. No questions about that. Question bank is more than sufficient. Okay, question bank is a superlative. It has a lot of questions, and you cannot I cannot expect you to complete the question bank if you start now. But MCQs are easily solvable, and if possible, solve the numericals from the chapters which are important for numericals. Don't solve all the chapter numericals, but the chapters which are important for numericals, if you practice those chapters, then you should get full marks. Okay. But 2, 3, 5 markers, if you are following our channel, that is sufficient. We will not do the entire question bank. Entire question bank has a lot of questions. Each chapter has heavy questions. Okay, you don't need to do that. But MCQs are, yes, MCQs different varieties of questions can come, so you will get an idea. Okay, so question number 18, Nagaraj is saying B, 19A. So 18B is, yes, kinetic energy is positive. I already told you that kinetic energy is total energy is potential energy is twice of total energy. Total energy is given by minus 13.6 divided by n square. Okay, and kinetic energy is magnitude of total energy. Kinetic energy cannot be negative. Remember that kinetic energy cannot be negative at all, because kinetic energy is half mv square. M cannot be negative. V can be negative, but V square will be always positive. So kinetic energy is always positive, no matter what. For electron, for any system, kinetic energy cannot be negative. Potential energy and total energy are negative, because potential energy is negative. If you add these two, then only total energy can be negative, right? Now, according to Bohr's postulate, angular momentum of electron orbit around the nucleus is equal to an integer multiple of h by 2 pi, equal to an integral multiple of 2 pi by h, equal to an integer multiple of h square pi, equal to an integer multiple of 2h by pi. So 19A, yes, Pooja and Nagaraj both have answered correctly, equal to integer multiple of h by 2 pi. In Geiger-Marsden Rutherford alpha particle scattering experiment, when impact parameter is 0, then angle of scattering is 0, angle of scattering is 180 degrees, angle of scattering is equal to 90 degrees, alpha particle enters the gold nucleus directly. So, which question? What is the correct answer? So, when the impact parameter is 0, what is impact parameter? Suppose this is the nucleus and alpha particle is going like this. So this distance is called impact parameter, distance between the center of the nucleus and the alpha particle. This is not infinity, this is alpha particle. This is alpha particle. Okay, alpha particle, the distance between the trajectory of the alpha particle and the nucleus of the atom is called impact parameter. So if impact parameter is 0, it is straight away going towards the nucleus, and after the minimum distance of approach, what it will do, it will directly come back. So at this point, what will happen is the scattering angle will be 180 degrees. This is slightly tricky question. Even though it is given in an easy category, this is not super easy. Now next few questions are statement based questions. The atom is electrically neutral. An atom contains equal amount of positive charge to neutralize the negative charge of the electrons. Question number 21. So Nagaraj was saying 20B and Pooja was saying 20C. 20B is correct, Pooja, not 90 degrees. 90 degree means scattering is, if you are coming like this, if it is going like this, then this is 90 degrees. This is 90 degrees. This is not happening here. Here it is going like this and coming back like this. So the angle is a straight angle 180 degree. Okay. I know sometimes 90 and 180 people can confuse. Okay, it is coming back, going straight, coming back in the same path. That's why it is 180 degree. Now let's see. Atom is electrically neutral, and atom contains equal amount of positive charge to neutralize the negative charge. Both statements are true, and 2 is correct explanation of 1. Yes, 21 is A. 21 is A. Easy, right? Pooja? Nagaraj is also answered it, correct? Now 22. Many of the alpha particles pass through the gold foil in alpha particle scattering experiment. Only about 0.14% of the incident alpha particles scatter by more than 1 degrees. Both statement 1 and 2 are true, and correct explanation of 1. Both statement 1 and 2 are true, but 2 is not correct explanation. Statement 1 is true, statement 2 is false. Both statements 1 and 2 are false. What about 22? 21A correct. What about 22? What is correct? 22. So many alpha particles pass through the gold foil in alpha scattering experiment. This is a true statement. Okay, so most of the, actually what we are expecting, many of them will come back, because it was pump pudding model that we are testing on. Okay, pump pudding model says the atom is solid, so if alpha particle is going hitting the wall, it should come back directly. But while doing the experiment, we realized that most of the particles are going through the element, going through the gold foil. So that means atom is not as solid as it's supposed to be. Only about 0.14% of the incident alpha particles scatter by more than 1 degree. This is also true. But is it correctly explaining the reason? Is it the reason? Okay, this, even though both statements are true, this is not the reason. Reason is most space inside the atom is empty. That's why alpha particles are passing directly. So both 1 and 2 are true. They are actually experimental observations. Both are experimental observations. They cannot be the reason. Reason for both of them, reason is that most part of the atom is empty. Okay, that's why electrons are passing through. Alpha particles are passing through it. Okay, so both statements are true, but 2 is not correct explanation. Next question. Radius of the first orbit of hydrogen atom is smaller. The radius of its fourth orbit will be. Okay. Not 22C, Pooja, 22B. Both statements are true. Both are true individually, but it is not the explanation. So not C, but B should be the correct answer. It is not false. 0.14% actually scatter more than 1 degree. 0.14% means most of the electrons go straight, only 0.14% less than 1 degree, and even 1 in 12,000 that comes back directly. Okay. Answer this one. Radius of the first Bohr orbit is smaller. The radius of the fourth orbit will be. It is a kcet level question. 23C she answered first, then 23A. No. So Rn, remember this, Rn equals to n square into R0. Okay, so radius of nth orbit is n square times Bohr orbit. Okay, Bohr radius. So Bohr radius or first Bohr orbit or radius of the first orbit, they are all same. Here R0 is given as so Rn will be, here Rn is fourth orbit. So 4 square into R, so it will be 16R. 16R should be the answer. So 23C is correct, not 23A. So you answered it first correctly, then you changed your answer. That is not good, right? Oh, okay, sorry. Pooja answered 22C the previous question. Sorry, I missed 2. 23, not A, but 23C is correct. When an electron in hydrogen atom revolves in stationary orbit, it does not radiate energy though its velocity changes, does not radiate energy and velocity remains unchanged, radiates energy but its velocity is unchanged, radiates energy with the change of velocity. So what is correct? Tricky question. Tricky question. So when an electron in hydrogen atom revolves in stationary orbit, so let's see. So we have a positive nucleus and electrons is orbiting in a stationary orbit. So what happens to its velocity? So velocity means, remember, velocity is a vector quantity. So velocity at this point, say, is v. Okay, so now at this point it is again v. Are the directions same? Direction is different. That means different direction means the direction is changing, velocity should also change. What will not change? If you say that magnitude of velocity or speed will remain same, or if you want to say that angular speed omega is determined by the angle only. Okay, so angular speed omega will not change. Angular speed is only outside. Okay, direction wise also it will not change. So angular speed omega will remain constant, speed will remain constant, but velocity will not remain constant. Velocity is changing. Also, we know that according to Bohr's theory, if electron is orbiting around the nucleus in its stable orbit, it does not radiate any energy. Okay, so it's a stationary orbit, that means it's the stable orbit, so does not radiate energy though its velocity changes. Does not radiate energy though its velocity changes. Okay, 24A, yes, not 24D, Pooja. Okay, radiates, it does not radiate energy. Stationary means it does not radiate energy, whereas velocity is changing because the property of the velocity has to change. Its direction changing means velocity is changing, even though magnitude wise not changing, but direction changes. That's why velocity is changing. When a hydrogen atom is raised from the ground state to an excited state, potential energy increases and kinetic energy decreases. So hydrogen atom is raised from ground state to an excited state, potential energy increases and kinetic energy decreases. Potential energy decreases, kinetic energy increases. Both kinetic energy and potential energy increases. Both kinetic energy and potential energy decreases. Let's see. So remember that total energy at any state is given by minus 13.6 by n square. Okay, so potential energy is exactly equals to this value, twice of this value with the sign, and kinetic energy is magnitude of this value without the sign, that is positive. Okay, now if electron jumps from a lower orbit, that is say n equals to 1 to n equals to say 5, okay, the division is more, right? So in division initially it was 13.6 by 1, now it is 13.6 by 25. So kinetic energy is decreasing, but in terms of potential energy it was more negative before, now it is less negative now. So because the negativity is decreasing, potential energy is increasing. So electron is moving from lower energy, that is ground state, to higher energy, then its kinetic energy is decreasing, its potential energy is increasing. So kinetic energy is decreasing, potential energy is increasing. So option A is correct. 25A is correct. Yes, Pooja answered correctly. Next question. According to classical theory of atom, statement 1, the electron will fall into the nucleus. An accelerated electron emits radiation in its orbit. So classical theory is electron will fall into the nucleus, accelerated electron emits radiation of the orbit. Both 1 and 2 are true, and 2 is correct explanation of 1. Both 1 and 2 are true, and 2 is not correct explanation. 1 is true, 2 is false. Both 1 and 2 are false. So according to the classical theory is that accelerated charge emit radiation. So when an electron is orbiting in a circular path, it is an acceleration motion. It is an accelerated motion. Why? Because positive charge and it is a negative circular motion, velocity is changing, so centripetal acceleration is always acts. So centripetal acceleration is also an acceleration. So it basically it says that because electron is orbiting in a circular path, okay, and positive charge does have its own magnetic field, and accelerated charge in a magnetic field will slowly start losing its energy and fall into the nucleus. So statement 1 is true, statement 1 is true, statement 2 is also true. Both statements are true, so correct answer is option A. So option A is correct. Question number 27. In alpha particle scattering experiment conducted by Geiger-Marsden, in case of head-on collision, the impact parameter and the angle of scattering are respectively. We have answered this question in the easy part section. Answer it quickly. Okay. Alpha particle scattering, head-on collision. Head-on collision means again the same thing. So head-on collision means impact parameter is 0. So if impact parameter is 0, what is the angle of scattering? So 27 is also option A. We have one more chapter to go. Atoms is only done, nuclei is still done, until to be done, so we have to do it little faster. De Broglie hypothesis provides an explanation for J.J. Thomson's atomic model, Rutherford's nuclear model of atom, Geiger-Marsden experiment, Bohr's postulate of quantization of angular momentum. Yes. So quickly, 28. So de Broglie's hypothesis provides an explanation for Bohr's postulate of quantization of atomic angular momentum. Right? 28 is option D. 28 is option D, not A. And we are not doing the fill in the blanks because fill in the blanks are not important from this chapter. We will straight away move to the chapter nuclei. Another 25 questions are there, so try to complete them quickly. Okay, nucleus of an atom whose atomic mass is 24 consists of 11 electrons, 11 protons and 13 neutrons. 11 electrons, 13 protons and 11 neutrons. 11 protons, 13 neutrons, 11 protons, 13 electrons. Okay? Let's see who can answer this question. So, nucleus of an atom, atomic mass is 24. Here you have to remember that inside the nucleus there is no electron. Okay. So they ask you nucleus of atom. Okay, if they ask you about directly what the atoms is constituted of, then you can say 11 electrons, 11 protons, 13 neutrons. But they are saying nucleus of the atom is consist of. So nucleus of the atom should have 11 protons and 13 neutrons. Now remember that why one more combination could be there, that 11 neutrons, 13 protons. Remember that number of protons cannot exceed number of neutrons. At best they can be equal. Neutron number will always be bigger than the number of protons, bigger or equals to. Okay, so number of neutrons will always be greater or equals to number of protons. Okay, number of protons cannot exceed number of neutrons. Okay, that is also one reason. Here 11 protons, 13 neutrons is possible, so that is the answer. Isotopes are the nuclei having same number of protons but different number of neutrons. Same number of neutrons but different number of protons, same number of protons and neutrons, different number of protons and different number of neutrons. So isotopes means same nuclei, so they must have same number of protons, only different neutrons should be there. So 2A is correct. The radius of a nucleus of mass number A is directly proportional to A cube, A to the power of 1/3, A to the power of 2C. No, Pooja, 2C is same number of protons and neutrons, they are not isotopes. Same number of protons and neutrons, they are same nuclei, so they cannot be isotope. Isotope means same number of protons but different number of neutrons. 2B is also incorrect, Nagaraj. Same number of neutrons and different number of protons means that will be isobars. Not isobars, that will be isotones. Okay, isobar means mass is same mass number, isobar. Okay, same neutron number, isotones. Okay, radius of nucleus of mass number A is directly proportional to A to the power of 1/3. Okay, radius of nuclei having same mass number is proportional to A to the power of 1/3. Okay, that's why density of nucleus is constant. Nuclear forces are short ranged, attractive, charge independent, short range attractive and charge dependent, long range repulsive and charge independent, long range repulsive and charge independent. Let's see. 3D is correct. What about the question number 4? Let me drink some water. Question number 4. So nuclear forces are short range, attractive and charge independent. So option A. So one line for properties of nuclear charge. Density of any nucleus is 2.29. Now I don't remember the value, so you tell me what is the answer. Density of any nucleus is a constant, okay, and you can calculate it, but I don't remember it. 2.29 into 10 to the power 10 kilogram per meter cube, 2.29 into 10 to the power 17 kilogram per meter cube, 2.29 into 10 to the power of 12 kilogram per meter cube, 2.29 into 10 to the power 13 kilogram per meter cube. So Nagaraj is saying 4A. Yes, 4A was correct. 5. Answer the 5. I don't know the answer of 5. But I can guess it. I don't know the answer, but I can guess it. So density of nucleus is the one of the most dense object, okay, one of the dense thing. Not I won't say it's object. So nucleus have the highest density. Okay, nucleus should have the highest density. And what is the highest given here? Highest given is, yes, 2.29 into 10 to the power 17. If I have to guess, I will guess this one. Even if I don't know, I should know that the density of nucleus should be highest, and according to this value, this is the highest value, so I will say this. Binding energy of a nucleus is energy given to its nucleus during its formation, total mass of the nucleus converted into energy units, energy required to break the nucleus into constituent nucleons, total kinetic energy and potential energy of the nucleons in the nucleus. What about question number 6? So binding energy is basically the energy that is binding the nucleus together. It's like a glue. Okay, and if you want to take apart the nucleus, if you want to destroy the nucleus, then minimum amount of energy that you have to provide to the nucleus so that the nucleus can be broken. So this is the energy required to break the nucleus into constituent atoms. The energy required to break the nucleus into constituent molecules. Okay. Now, next question. The binding energy per nucleon is maximum in the case of helium, Fe, barium or uranium. So binding energy per nucleon is maximum in the given case is helium. Okay, helium is one of the stable atom. Also it is a new you can say this is a inert gas. So inert gas means it is one of the stable nucleus. Stable nucleus means binding energy per nucleon will also be maximum. So after hydrogen we see a peak with helium. Helium, even though it has only 4 nucleons, okay, its binding energy is quite high. So binding energy per nucleon is much higher for helium compared to Fe. Fe, even though it's a constant, it's coming in the constant range, binding energy, it has 56 nucleons. So binding energy per nucleon is not that high compared to helium. For effective nuclear forces, the distance should be 10 to the power of minus 10 meter, 10 to the power of minus 13 meter, 10 to the power of minus 15 meter, 10 to the power of minus 10 meter. I don't know why two options are given same. Okay, here two options are given same. Hello Manish. What about 7B is actually correct, not 7A. Sorry, my mistake. Somehow, even though helium is one of the stable atom, its binding energy per nucleon is not that high as compared to Fe. Okay, actually it will be Fe. Sorry, it will be Fe. Okay, not helium. Hello, Manish. What about the nuclear forces? Distance should be so it should be of the order of fermions. So fermions means what? Fermions means 10 to the power of minus 15. Okay, 1 Fermi is 10 to the power of minus 15. So we know that nuclear force up to 0.8 Fermi is repulsive, from 0.8 Fermi to about 2 to 3 Fermi is attractive, and beyond 2 to 3 Fermi it is 0. So it has to be in the range of 10 to the power of minus 15. Fermi is 10 to the power of minus 15. Two nucleons are separated by a distance of 1 into 10 to the power of minus 15. The nuclear force between them is F1. Two nucleons are separated by a distance of 1 into 10 to the power of minus 15 meter. The nuclear force between them is F1. Both are neutrons. If F2, both are protons. F3 is one is proton, another one is neutron. Then which one is the correct relation? So we know that nuclear force is independent of charge and it is 1 Fermi. So this is attractive in nature and all forces should be same. All forces should be same. Next, radioactivity is reversible process. Now radioactivity is, even though it is deleted, basic definition is there. It's a reversible process, controlled process, spontaneous process, cyclic process. So radioactivity is a spontaneous process. It cannot control it. It happens spontaneously. So this is called spontaneous process. Which is not found during radioactive decay? Emission of alpha particles, emission of beta particles, emission of X-rays, emission of gamma rays. So during radioactive decay, generally emission of X-ray is not found. Alpha, beta and gamma are observed during Pooja came back. So 10C, let me see what is 10, I missed it. 10C is correct and 9C is also correct. Both are correct. 9, 10 both are correct. What about 11? Which is not found during radioactive decay? Alpha particle is can be found. Beta emission is basically the emission of electron. Emission of gamma rays is also there, but X-rays are not found. So during radioactive decay, X-rays are not observed. Fusion reaction takes place at high temperature because atoms are ionized at high temperature, molecules break up at high temperature, nuclei break up at high temperature, kinetic energy is high enough to overcome the repulsion between nuclei. So what answer it could be? Question number 12. Yes, previous one is C correct. Question number 12, very easy question according to the options. Okay, so according to the option, this is a very easy question. Quickly, we have a few more questions to go. Okay, almost hot questions are there. 20 questions are there in this chapter. So we are at the 12th question. So after that, 7 questions have to be completed quickly. So fusion reaction takes place at higher temperature. Remember, in some cases, if the option is longer, then it tend to be a correct answer. Okay, kinetic energy is high enough to overcome the repulsion between the nuclei. So when you are fusing two nucleuses, it is easy to break up. Okay, nucleus always try to breaking up to find stability, but when you are fusing two stable nucleuses, they are repelling each other with a very high force. To combine them together, you need a very high amount of kinetic energy, and to gain that kinetic energy, you have to provide them with a very high temperature. For example, few billion degrees Celsius that is there in the sun. Okay, and at that high temperature, two hydrogens are getting fused, 4 hydrogens in fact getting fused to form helium. Okay, and once all the hydrogens are burned, then helium will start to fuse, and so forth and so on till iron. Okay, after iron, no other element is possible, because iron is the most stable element. Okay. The explosion of the atomic bomb takes place due to uncontrolled nuclear fission, scattering, thermoionic emission. So atomic bomb. Pooja is saying 12C. 12C, no, 12D. Okay, not 12C, 12D. Okay. Our goal is fusion. Fusion means mixing, adding. Okay, we are not trying to break them up. Okay, breaking up is not our goal. Our goal is to unite them. To unite them, what we have to do, we have to give them very high temperature, so that they can gain high kinetic energy, and at high kinetic energy they will fuse together. Okay, to overcome the repulsive force. Repulsive force is very high. When they get very high temperature, they can get closer and closer, and they can combine. Okay, the explosion of the atomic bomb. You want to drop an atomic bomb? Uncontrolled nuclear fission. Okay, uncontrolled nuclear fission. You don't want to control it. You drop. You devise something which works on the fission, and you don't control it. It will blast, right? Energy generation in stars mainly due to photoelectric emission, fission of heavy nucleus, fusion of lighter nuclei, fusion of heavy nuclei. What is question number 14? We know 13B is incorrect, 13A is correct. Not nuclear fusion. Nuclear fusion is now atomic bomb generally refers to nuclear fission. Uncontrolled nuclear fission. Nuclear fusion is basically called hydrogen bomb. Okay, and hydrogen bomb, no matter what, so there is a saying that if you want to explode an hydrogen bomb, first you have to explode an atomic bomb. Okay, atomic bomb is necessary to fuse, the heat and temperature is necessary to fuse hydrogen to gain even more energy. Okay, so there is only one instance when hydrogen bomb was dropped, which is basically uncontrolled fission plus uncontrolled fusion as well. Energy generation in stars is mainly due to fusion of lighter nuclei, namely hydrogen, helium, etc. Okay, so the option is so weird. Photoelectric emission. Can you imagine that energy generating in stars due to photoelectric emission, which is very, very weird. Fusion reaction is initiated with help of low temperature, high temperature, neutrons, protons. Fusion always requires high temperature so that kinetic energy is high. So fusion always, to perform fusion in Earth, we have to blast an atomic bomb first. So fusion, to observe fusion or to do fusion, we have to have a atomic bomb blast first. Then we can do some fusion. Okay, and that's why fusion is not able, we are not able to control fusion. Fusion is the most difficult aspect of atomic theory. Okay, we cannot control fusion. If we can control fusion, then it will give us enormous amount of energy without any pollution. Okay, so that is the benefit, but we cannot do that. So imagine that what we are doing, we are taking hydrogen, we are fusing, we are forming helium. Both are harmless. Hydrogen is harmless, helium is also harmless. But if you are doing nuclear fission, okay, we are breaking uranium. Uranium is radioactive, and when it breaks into any other daughter nucleus, they are also radioactive. So radioactivity basically harms you, but if you are able to do fusion, then that is a clean energy, but that is not yet achieved in our Earth. Okay, 22688 radium nucleus, there are 138 protons and 88 neutrons, 138 neutrons and 88 protons, 226 protons and 88 electrons, 226 neutrons and 138 electrons. Yes, 14C, 15B. 16. So radium 22688 means the mass number is 226. The atomic number, that is the number of protons. Atomic number is number of protons. It is given by 88. So what is the number of neutrons? Number of neutrons is given by 226 minus 88, that is 138. Okay, so number of neutron is 138 and protons are 88. So correct answer is option B. The mass and energy equivalent to 1 U respectively. Mass and energy equivalent. So if you know the energy equivalent, mass equivalent is not required. Mass and energy equivalent of yes, Nagaraj already answered 17D. So remember that the energy equivalent of 1 U is 931.5 mega electron volt. Corresponding mass is 1.66 into 10 to the power of minus 27 kg. Question number 18. Mn and Mp represent the mass of neutron and proton respectively. If an element having nuclear mass m has n number of neutrons and z number of protons, then the correct relation will be mass is less than Nm into Zmp, mass is greater than Nm into Zmp, mass is equals to Nm into Zmp, or mass is equals to N into Mn plus Mp. Which one is correct? So this is the rest mass, and remember that there is something called binding energy, and binding energy is basically the factor which is the difference of atomic nuclear mass, total nuclear mass subtracted from the mass of the nucleons. Okay, so this is the total mass of the nucleons. Total mass of the nucleons will always be greater than the individual mass. Okay, so individual mass or mass of the nucleus should always be less than that of the mass of the nucleons. So correct answer is option A. Question number 19. This is last. Okay, we have how many questions? Oh, we have 25 questions in this chapter also. Two nucleons are separated by a distance of 1 into 10 to the power of minus 15 meter. The net force between them is F1 if both are neutrons. F2, I think we have already answered it. Okay, mass between neutron, proton, and proton, neutron are same. So it is F1 equals to F2 equals to F3. Which of the following is a fusion reaction? Which of the following is a fusion reaction? What you are saying, Rider Hi-Fi? Why it is no? Oh, I think hello. Hello, Rider. How are you? We are almost done. We are almost done with the lecture. Only 5 more questions are there. Fusion means what? Fusion means when multiple nuclei fuse together to form one or more new nucleus. Okay, so lighter nuclei, they are fusing to form slightly heavier nuclei. So here only one case where two lighter nuclei fusing to form a heavier nuclei. So this is the example of fusion, when two deuterium atoms are fusing to form a helium. Okay, here also it is a breaking, here it is also a breaking, here it is also breaking. Okay, match the following columns. Isotopes, nuclei having same number of neutrons, nuclei having same number of protons. So isotopes are nuclei having same number of protons. Isobars, nuclei having same number of nucleons. Isobar means same mass, that means nuclei is having same number of nucleons, and isotones are same number of neutrons. Okay, so A is with 2, A matching with 2, B is matching with 3, so A with 2, B with 3, C with 1, so correct answer is option A. Matching questions can be tricky at times, so be careful. Next is among the following set of nuclei are isotopes. Which of them are isotopes? So isotope, as I mentioned, they has to have the same symbol. So isotopes are easy to identify. So if you see that uranium and uranium, both of them are uranium, both of them have same number of protons, so this must be the isotopes. Among the following, which of the nuclei are isotones? Isotones are tricky. You have to calculate the number of neutrons in both of them. So what is the number of neutrons in this case? So if you calculate 14 minus 6, that is equals to 8. So number of neutrons in carbon 14 is 8. What is the number of neutron is oxygen? 16 minus 8. So this is also 8. So number of neutrons in both these cases are same. So these two are isotones. Okay, we have not gone into any other calculations. Okay, but isotones can be tricky, so you have to find the difference between these two numbers, and if they are equal, they are called isotones. Okay, isotones means difference should be same. Isotope means these two numbers should be same, and isobar means the top two numbers should be same. Okay, if top two numbers are same, isobars. If bottom two numbers are same, isotopes. And if the difference between them is same, they are called isotones. Okay, clear? Yes, Nagaraj, 23A is correct. Okay, so this is the end of this lecture today. The lecture extended slightly more than 1 hour. I tried to finish it as quickly as possible. But anyway, so the lecture is finally over, and if you have any comments, any suggestions, don't forget to give it into the comment section below, and also subscribe to our channel, and obviously join the WhatsApp channel if you want to download the PDF of this lecture. I'll be back with a new lecture. Till then, bye.